Okay, today we're going to talk about surface area, and I think you're going to like this better. We're going to be just doing a lot of calculating, not so much drawing and having to see the visual stuff, and it's just kind of more easy. So first of all, is to get a little bit of vocabulary out of the way. Every polyhedron is made up of bases and lateral area. The bases are the flat surfaces. So pyramids have one base, prisms have two, cylinders have two, right, here and here. Okay? And when we talk about the base edges, we mean the areas or the edges that surround the base, where the lateral area connects to the base area. Okay? When we talk about lateral edges, we're talking about the edges that connect the lateral sides. So these two would be lateral edges. And then this one down here would be the base edge, another base edge. Okay? And when we talk about base area, like in a triangle, we know like this was base times height. And so when we're talking about just a line, we use a small b. When we're talking about the area of the whole base, we call it the big B base. And that's the way I'll refer to it. So when we're talking about the area of the whole base of the polyhedron, we call it the big B base, the area of the base. Okay? All right? Lateral area then is the area of all the sides. Okay? So for instance, in the cylinder, it would be the can part, not the top that you would take off to get the tuna out, but the can part. To find the area of a prism or right prism or a cylinder, you would just take the area or the length of the perimeter times the height. And we'll talk about that a little bit later. That's sort of a shortcut. All right, surface area is the total area of all the faces and curved surfaces of a three-dimensional figure. So to get that, we are going to draw a net, okay, and calculate all the different faces, area of all the different faces, add it up, and that's going to be the total surface area. Okay? In this case, we're going to find the lateral area first. So we're going to find the area of all these like see-through pieces, and then we're going to add them to the bases to get the total surface area. So the lateral area of any prism, remember, is always a bunch of rectangles. In this case, since it's a triangular prism, there's going to be 3 rectangles that connect those triangles. And this is I can tell by 5 and 5 and 4, this is an isosceles triangle. So when I draw it, I'm going to have an isosceles triangle here. Then I start labeling the stuff I know. So I know the distance between the bases. So from here to there is 9. So that's 9, that's 9, that's 9, this is 9. All the distance between the bases is 9. The length of the short side is 4. And then these two sides are 5, which means these are 5 as well, because they have to connect exactly. Okay? So to find the areas of these bases, of the lateral area, that's easy. This is 9 by 5, so that's 45. And 4 by 9, that's 36. 9 by 5, 45. So the lateral area is, that's LA for lateral area, 126. Okay? Then I'm going to draw in this height, because I know my base is 4. My height is going to be, if this is 5, this is 2, because it's an isosceles triangle. I know it divides it in half. So 25 minus 4 is 21. So I know my height is a square root of 21. So 1/2 times base times height, 1/2 times 4 times square root of 21 is 2 square root of 21. And there are 2 triangles. So this one is 2 square root of 21, and this is 2 square root of 21. Okay, add them together, and I get 4 square root of 21. Now, if they ask me for an exact surface area, that's what I would give them. But if they ask me for the estimate, then I would go ahead and plug that and in my calculator, and when I plug that in, I get 144.34. Okay. Lateral area is the 3 rectangles. The bases are the 2 triangles. Okay. Take a second and calculate this prism here. Okay. So hopefully you got those answers. All right. A cylinder is a little bit different because the bases are going to be the same, but the lateral area, you just have to know a trick. And that is, we talked about this the other day, if you think about the net of a cylinder, it's a rectangle that connects the 2 bases. Okay? And we said the length of the rectangle is the same as the perimeter of the circle because it has to fit around exactly. So if this diameter is 16, that means the radius is 8, and we know that the perimeter is pi times diameter, so that's 16 pi. So the length of this rectangle is 16 pi. Okay, they gave us the height as 10, and we know the area of the circles are pi r squared. Okay, then I just multiply that all together. So I do 64 times pi, and I get 201.06. Okay, and same thing over here. And then the base is 10 times 16 times 3 pi. And that's 502.65. Then I add them all together. And that gives me, so this is 502.65.
A couple of quick announcements. Tomorrow is the final Interact Service Club general meeting.
So your final answer would be, if you had the basis, which is 502.65, the lateral area, the basis, which is 402.12, you add those up, you get 904.77. Okay, now see if you can take a minute and solve these, and we'll check your answers tomorrow.